The following is an ESG Lab video.
Welcome to another ESG Lab video summary, where I'll be reviewing the results from our recent testing of the EMC Converged platform's VxRail Appliance. It's not surprising that 85% of respondents to a recent ESG survey already use or plan to use a hyperconverged solution in the coming months. From improved service and support, improved scalability, and increased agility of VM provisioning, to simplified management and speed and ease of deployment, organizations are rapidly adopting hyperconverged technologies, whether it be to house key business applications or to leverage a lower cost of entry for just getting started with virtualization. ESG Lab looked to validate the VxRail's ability to deliver on these core factors with a key focus on ease of deployment, scalability, performance, and high availability. The VxRail Hyperconverged Appliance is a clustered node architecture that brings together compute, storage, and virtualization in a single infrastructure in a box. Common IT resources are converged into a scale-out building block, with the primary value being around simplicity, making acquisition, deployment, management, scalability, and maintenance fast and easy. The underlying architecture leverages software-defined storage across multiple nodes to provide low-cost entry points for organizations looking to start small and grow, while also handling mission-critical applications in production environments. Each VxRail appliance contains 4 server nodes, each with direct attached storage and ready to attach 10 gigabit interconnects. A distributed system architecture serves as the foundation of the appliance and uses VMware technology to virtualize compute, storage, and networking, with each of the nodes getting configured as an ESXi host. Specifically for storage, VMware virtualization software is leveraged to pool the storage from each node. First, we walked through the deployment of a new appliance. We logged into the appliance for the first time and followed guided steps to configure the appliance. This included going through a setup checklist and completing a step-by-step configuration. The steps focus strictly on VMware configuration information related to networking, so IP address allocation and assignment for core management, VMware vMotion, VMware Virtual SAN, VM networks, and logging and manager extensions. It should be noted that since this testing took place, the process has become even easier, with the manager extension being incorporated directly into the VxRail manager. Lastly, we built the appliance based on the configuration information, which simply entails clicking a button and watching the build process work through the deployment of all the components. Overall, it took just 20 minutes from power on to having an operational VxRail appliance. The deployment was scaled by adding an additional appliance. We found this process extremely impressive. After powering on the new appliance and connecting it to the network, it was automatically discovered, and with just a couple clicks, in less than 5 minutes, a new appliance had been added to the deployment, doubling the available resources. We audited performance results run by the EMC team with the goal of confirming acceptable levels of performance. Baseline performance tests showed the appliance achieving over 250,000 IOPS on a single appliance for pure reads, while workloads that mimicked common OLTP databases, both reads and writes, averaged over 155,000 IOPS. Also important to mention is the latency measurements, which delivered consistently low response times that never exceeded 5 milliseconds. This mix of high IOPS and low response times combined to appeal to organizations of any size that look to not only meet application performance requirements, but also deliver positive end-user experiences. Finally, we looked at the high availability capabilities of the VxRail. Starting with a healthy appliance, we began playing an HD video from within a VM. Components were then systematically failed while playback was monitored. As failures occurred, health alerts displayed in the GUI on the failed physical components. As expected, the HD playback continued uninterrupted as an interconnect, drive, and power supply were disconnected from the appliance. So why does all this matter? The pre-integrated, pre-configured, and pre-tested hyperconverged solution leverages VMware's hyperconverged software and VMware Virtual SAN, along with common management interfaces through VMware vCenter Server. This provides a common and familiar VMware experience while enabling deployment and management flexibility. Customers gain peace of mind knowing the VxRail comes standard with enterprise-grade features and functions extensively developed and deployed by EMC and VMware, such as compression, deduplication, replication, and backup services. And all of this boils down to a rock-solid, fully virtualized, software-defined data center environment that's ready to handle the strict service-level agreements common in organizations today. With the traditional IT approach, the amount of time needed to plan, deploy, install, configure, and validate a virtualized infrastructure can take months because of the disparate resources and management complexities. EMC and VCE not only reduce these complexities, but also completely eliminate them in some cases. While the software-defined data center has seemed out of reach for many organizations, EMC and VCE have developed a joint solution that provides the mechanism to make it a reality, the VxRail Hyperconverged Appliance. If you'd like to learn more, read the full report.